Hi everyone, in this video I want to talk about graphing sine and cosine functions along with amplitude and period. And here are the two problems that we'll do. To make sure we don't take ourselves too seriously, let's think about the fun question. What is a goal that you have set for yourself in your past that you were proud that you achieved? So let's get into the math section as a whole. It's possible that you would have a question on trigonometry graphs, like graphs of trig functions. It's very rare that you would see tangent. It's more of the basic graphs of sine and cosine. That's written in the standard for, as one of the trig standards. So let's talk about how to graph graph functions given an equation. Let's also talk about amplitude and period because those are the basics that you need to know in order to be able to graph. So if we remember amplitude and period, there are formulas for them. But in order to understand the formulas, we have to think of this layout as like A cosine bx. Okay, so the amplitude is always the A. And then the period is always 2 pi over, and then the absolute value of the B. That's only for sine and cosine, by the way. So the A here is the amplitude. Amplitude for the first one is 1/2, and then the period would be 2 pi over 2, which is just pi. Simplifies to pi, the 2's cancel. Okay, so that tells me that this graph will go as high and as low as 1/2 and -1/2, and then it'll span a distance of like 0 to pi, and then it'll just keep repeating. So what I think is best to do first is think of just cosine x rather than this fancier version. In order to do that, you need to know some things about the unit circle. So I have that kind of screen clipped here. If we plugged in 0, say for x in that situation, 0 would be our input, and we need to know what the output is. So throw in 0, and cosine of 0 is what? You need to know that it goes cosine and then sine, with these points right here. So what's the cosine of 0? It is 1. So I'm going to do 0, and then if the cosine of 0 is 1, what is the cosine of, we'll just go to the every, axis here. So plug in 90, or in radians, it says, in the directions we need. So we'll do pi over 2. See, it says using radians as opposed to degrees. We'll do pi over 2 and then pi, 3 pi over 2, and 2 pi. So if you plug in pi over 2 as your input, your cosine is here, 0. And then if I do pi, cosine is -1. If I do 3 pi over 2, the cosine is 0. All right, so 0, -1, 0, 1. And then the shape of a sine or cosine graph is a wave. You could probably see why. It's just going 1, 0, -1, 0, 1, 0, -1, 0. So that's why it's making sort of a wave shape. So all of you, anytime you see a wave on the ACT, it would be related to this concept. So I know that if my amplitude now is 1/2, this graph is not going up to 0, 1. Remember, this is the regular cosine x graph. I need to then remember that it's the same curve as cosine. So like 0, 1 is here. Regular cosine x looks like this. That's me just graphing these points right here. But if I'm changing the period to be pi and the amplitude to be 1/2, then the points are going to be as far up as 1/2, not 1. And that whole U shape is going to be, spanning from 0 to pi now only. So it's going to be, 1/2 here. Then we'll go to 0, -1/2, 0, and 1/2. So that's one period of this curve. And then you can basically just follow that same pattern for another period next to it. For the next one, it's a sine curve. And so the sine curve is the same thing. It's just instead of starting up at this amplitude here, it would start at 0. It's a little bit more offset. So let's get the just general graph down x, and we'll do sine of x. Note, this says theta, but theta and x would be the same thing. They're just variables. So if I threw in 0 for x, and then I do sine of 0, so like all of this needs to be adjusted now. So at 0 now, what is the sine? Meaning, what is the y? It's 0. So that's why this, it's the same curve, but it starts at 0. So 0, 0, then we'll do pi over 2, pi, 3 pi over 2, and 2 pi. If I threw in then pi over 2, it's going to follow that same pattern. So at pi over 2, what is the sine? 1. Then we'll go 0. Then we'll go -1, and so on. 1, 0, -1, 0. So let me graph that. And we must remember that the amp and the period are going to change that graph a little bit. So the amplitude is 3, and the period is 2 pi over 4, which is pi over 2. So, okay, period is pi over 2. That means that an entire one of those curves that kind of looked like an S needs to fit from here to here. So it's going to be very scrunched, and it's going to have an amplitude up to the 3. So we'll go point here, and then the next point is going to be here, back through here, and then down to -3, back to pi over 2. So it almost looks like a sine curve. It just got elongated up and down and then scrunched inwards. And then that's only one period, so then it would just continue in that same motion going forward. So what you're looking for is a graph that had an amplitude of 3 and had a period that made it a little bit more scrunched in from the sides. So try these two practice problems. They are very similar. Find the amplitude, find the period, and then graph. Now, as a note, you wouldn't have to graph this by hand on the test, but you might be given the graph and asked to find the equation. It's smart, though, to go kind of forwards instead of backwards while we practice so that you know the ins and the outs of graphing it by hand fully. So feel free to pause the video if you'd like to see these problems without the answers yet. Okay, here are the answers. So the period was goofy on this first one, 2 pi over 3. So one full curve is fitting between here and 2 pi over 3. And then the period would be, from 0 to pi, and then pi to 2 pi. This whole curve is fitting between 0 and pi. Amplitude is 4. So I will leave you with a quote. Even though you're growing up, you should never stop having fun. Wonderful way to live by. So I hope this video benefited you in some way, and feel free to leave your answer to the fun question in the comments. If you would like to keep up with new videos, I would love if you subscribed. Thank you.